Hey, what's up? So I'm going to demonstrate how to get the ellipsoid ground distance in various spots. Okay, so this is kind of the laydown of what I'm got going on. So the stuff in yellow, so from LA to Chicago to Washington, Philadelphia to New York. So I got all those distances, ground distances, without using Google Earth. Okay, so, and how would I do that? So I'm going to show you how it's done. First, you got to, I just picked a random point here, downtown LA, so I go to the NGS website for the survey marks. And let's see here. So I go to this website here, and it's got every mark from known to man. It's got everything you want. So I happen to choose this guy right here. If I zoom out, it's 6th and Broadway. So so 6th Street and Broadway. That guy right there. So I would click on it, open it up, but I already got it open, which is this bad boy right here. Okay. So I need to get that into Civil 3D. Okay, so first thing I need to do is to let me show you what it is exactly. Where's Facebook at? It's basically this guy here, the Cartesian Coordinates XYZ allow the geodetic quality three-dimensional positioning on Earth, centered ellipsoid. So the utilities in this package provide methods for converting between geodetic latitude, longitude, ellipsoid height, and XYZ on the GRS80 ellipsoid. You probably don't understand that, some of you. Anyways, so and I get this from Jesse Kolosky. He's a geodetic surveyor. So, and let's see here. So Jesse says that he watched my video. So the marked mark will be shorter than the ellipsoid distance, which is the survey marks, which is basically the chord. and then I draw in the arc. Okay, so think of it as the chord length, kind of like, and the ellipsoid, the arc length, sort of. Can you, and then blah blah blah. So, with that said, let's see what it says. Anyways, I got my drawing, and right here, which you probably don't understand it, but I'll show you. So, that's the origin point right here, which is 0, 0, 0. So is how let me see here. I know I need to open up that. So I open up this bad boy here. X, Y, Z, when. So I want to convert latitude and longitude to X, Y, Z. So I get the latitude, ellipsoid height. So I come back over here to the data sheet for Los Angeles. And so the position here, so it's 34 degrees north latitude. So copy that, paste it. Okay. Now we need the longitude, which is this guy right here. Now I need the ellipsoid height. And so I need to use the geoid height. So I come over here to and get a rough estimation of the elevation. So I circle around here so you can see it right here on the lower left-hand corner, or lower right corner will give me the elevation. So I read 264. So my drawing's in meters, so I'll have to convert meters to feet. So 264 meters to feet. Or wait, the other way around. My bad. So 80 in my little calculator. Paste it. Minus. Back to the data sheet, and I need this minus this number right here. Convert calculator, minus, paste it, and equals. So that's my number right there. So then paste that in there, and then I say convert. It spits out these numbers. Okay. So with and with Civil 3D, got a point number. It's PNEZD, which is the point number, northing, easting, elevation, and description. And so we got 1259, 1259. I'm just reading the last four numbers. 64, blah, 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 4374, 4374. And then I just gave it another point, so I have two lines, or 2 points to create a straight line. And so I just over here, I just like added 250 and I converted it, and then that's how I got my other number for this right here. Okay, with that said, so now I need to paste that bad boy into Civil 3D. Okay, which I've already done, but I'll do it again. So I made a copy of the Calais one. So I go import. Let me close some of this stuff I don't need. I don't need that open. I don't need that open. And leave that. I've already explained kind of what it is. It's in 3D. It's not in 2D, so it's a little more complicated. And right here is the ground surface. That's what I'm after. Okay, so we'll get rid of that. So next, import my data. Seems like I'm always doing an update when it is crap. Okay. So I made a copy with different point numbers. So I just made a copy. So I'm going to import this one. So I want PNEZD, comma delimited. Next. Everything's good. And finished. And it slaps it in there. Normally when we do topo, it's in plan view. It's not in 3D. It is 3D, but it's not like what I'm doing here. Alright, so they should land exactly on top of each other, which they do. So I come over here and change the style. That one. And where's 26 or 24? So come over here and I want a dot. I want a box. So change that to box. Point label style. I want it to be a point. And then I can drag it. drag it. Okay. So you can see they ended up, that's where they are. I don't do no manipulate. I don't like move them around or nothing. So it is what it is. But we'll go ahead and delete those. I don't need them. Delete. Okay. So we'll come over here to Google Earth and we'll measure from that point, 6th and Broadway, to the Sears Tower. I got 1746.05. Okay. So, come back to my drawing. And here's the chord between those two from the Empire State Building, which I have the top and the bottom. It's, what do I got for the height? 1,481 feet tall. Okay. So, but we know that's not the distance because I got 1732 and well, that says 1746, so it's a few miles off. So that's the chord. So it's what I did. I did a 3-point UCS from that point to the center and then back up to get the delta angle, which is this guy right here. So I do my curve calculator. And I punch in those numbers, 25.2210. Change the radius to delta because I want to know the chord now. The chord distance in meters. Come on. So I need that number right here. .1460. And now it gives me the arc distance. But that I can't really draw it like that, so I need the mid-ordinate distance. So I need this guy right here. Okay. So then I would change my UCS again and draw from the center up, which that should match that, which it does. 1530 or 153,995 down here. 153,995.85. Perfect. Okay. And then I just do a 3-point from here to there to there. Okay. And so then this distance, arc distance, is I need to convert it to miles. So I need meters to miles. So I got 1746.08. I'm back over here to Google Earth. I got 1746. So it's a hundredth off. Wow, that's pretty impressive. Okay. And I can do another one real quick. We just check from here to the Washington Monument. So it should be around 595, 63, or 62. So I got labeled here. I got the top and bottom of it, which is 555 feet tall. And so we'll check that distance, that arc distance. So I got 595.63. And that says 595.63. Wow. And I could do the rest, but that takes more time. They're correct. So, let me see. Let me get this into a different view. That's not what I wanted. I wanted 4. No. Yeah. So we can see an arc here. We can see another arc here. Okay. So let me see here. So this is the perfect circle of the globe. And I got the ellipsoid behind it. Let me send that to back. Okay, this guy right here. It's a 3D solid, but it's the ellipsoid. So how that works is it's wider at the equator than it is at the North Pole. And it's blue. And so the Earth, the sphere, is in red. So let me the realistic. That's why you see red and blue. So the blue, like if I zoom in, is going to be blue. It won't be red because it's an ellipsoid. So if I go up on top, it's going to be red. Should be more red. There we go. See how it's all red? Alright. So here's the kicker. How does it fit these arcs on the surface? And you can see that they fit pretty snug. So if it didn't work, this arc that I created, it would be like inside, and you wouldn't even see it. So it's like right on there, hovering the globe, I should say. So I've never done this type of drawing. Like if I open up a drawing in, let's see here, like a regular survey drawing. And so I pretty much topoed this here. This is in Pratt, Kansas. I pretty much topoed maybe half of it. But it's plan view, so it's not in 3D. It's totally different. So if I go, let me even try that, see what happens. Might freeze up. I guess the surface, of course, will be 3D. But that's not how we do it. We don't, you just don't do it like that. So you, when we design, it's in plan view, which is top. Versus this one, it's more complicated. I mean, they're both complicated. But if I go top view here, it doesn't look like much. So, anyways, I think that was pretty cool. That how that works. Cool beans. Peace out.